Hi, welcome to the Shiko Math Lab Mathematical Statistics Problem Solving sections. So today, for this problem is related to the sufficient statistic concept. So let's take a look. Okay, so right now we have a discrete random variable x and with the following probability mass function. So it's p the x thetas here. So the theta here could be theta 1, theta 2, theta 3, and the x is 1, 2, 3. As you can see, when the theta 1, so then you add all the x value 0.1, 0.7, 0.2 together is 1. So the same is the theta 2 and the theta 3. Okay, so now, the first problem is here. They said, I want to define the statistics t. And t, this is like so how do we define this statistic? We say if x is odd, then I let t equal to 0. If x is even, then I will let t equal to 1. So I want to find the conditional probability of x given t, then put into a tabular form. Then let's take a look. After we see the tabular form, let's take a look at what type of the nature of these statistics here. Right, so this is a very interesting problem, cover the conditional probability concept, and also how do we do the conditional based on the discrete random variable, and what type of the statistics, also like we talk about the sufficient statistic concept here. All right, let's go ahead and start to work on these problems here. All right. All right. So in order to be easy to work, I move that table to here. So and we can work together. So instead of go back and forth to see what is the values here. All right. So here we talk about here we want to find is the probability given x given t, right? So by using the conditional probability, so we know this one is the probability of the t and the probability of the x and the t here. Okay, so now let's see here. So that means, okay, so for t, right, so it's t equal to 0. Okay, so that means this one's here is a probability of x given t equal to 0 will be equal to probability the t0, then probability x, right? X equal to x and t equal to t, t equal to 0 here. Okay, all right, so now let's take a look here when t equal to 0 here. So let's see here. So how do we do the t equal to 0? So let's do this tabular form here. Okay, so my x value still is 1, 2, 3, right? When t equal to 0, my, the based on what was the definition of the t, so we say t equal to 0 if x is odd, right? From the previous page, t equal to 1 when the x is even. All right, so now for theta 1, okay, so for theta 1, because t equal to 0 here, correct? T equal to 0, so x should be odd. So this is the ones, right? So then so that means it will be here and here. Okay, so that means when the p equal to 0, so will be included, the 0.1 and the 0.2. So so my denominator will be the 0.3, right? Because it's 0.1 plus 0.2. Then on top of here is what is 0.1. Then because t equal to 0 when the x is odd and t equal to 1 when the x is even. So here that we don't have any values here. Then here this will be 0.3 to the 0.2. Okay, so the same thing for theta 2 here. Still, x is the odd. right? So x equal to r here. So it will be pointer, so 0.2 and the 0.6. So what is here is 0.6, right? Then the top here is 0.2. Then because this is t equal to 0, so not including the even number. So then this probability here is bigger than 0.6, the 0.4. Then the same way for theta 3 here. So it's this number, this number. So the bottom will be 0.9. This is a 0.3, 0, and this is a 0.6, 0.9. Okay, so now let's simplify. So theta 1, theta 2, theta 3. So this is x is 1, 2, 3. So 0.1, 0.3. So this is 1/3, 0, 1/3. 0.2 over 0.6. Oh, wow, it's 1/3 also. 0.4 over 0. Is 2/3. I'm sorry, here this is 2/3. Okay, so 0.3, 0.9 is 1/3. So this is 0. 0.6, 0.9 is 2/3. Oh, wow. It's all the same. That's pretty cool. Okay, so now let's take a look at t is equal to 1 here. All right, so when t equal to 1, that means we only care about when x is even numbers here. So let's see here. So this is x. So this is theta 1, theta 2, theta 3. And because the t equal to 1 is x equal to the even numbers here, right? So that means this is the only one consider. So when x equal to 1, 2, 3, so here going to be 0 because it's not included. And so what is the here? So this will just be the 0.7 over 0.7. Then this is 0.4 over 0.4. And then this is 0.1 over 0.1. So let me simplify that. So this is x. So theta 1, theta 2, the theta 3. This is 1, 2, 3. Excuse me. So here will be 0, 0, 0, 1, 1, 1, and 0, 0, 0. Okay. So that is, that is what is our, the distributions, the conditional distributions in the tabular form. Okay. So also the part B, they say what type of the statistic is this T here? So we said that T is possible is to be a what? It's a sufficient statistics. So let me try to, okay. So let me try to give the definition. Let's try to review the sufficient statistics. So if we talk about the sufficient statistic is f of x, the given t, all right, given t does not depend on your parameter theta, okay? Then we can say, then we said that means t is sufficient for theta here. All right, so this is our definition for the sufficient statistics here. So now you take a look at this conditional distribution. So for the first ones here, as you can see, the t, this distribution is all the same, right? So 1/3 and 2/3. It doesn't depend on the theta value. So the same things here for the, the t equal to 1. So also does not depend on the theta value. So that's why we say here the t could be the sufficient statistics for the thetas here. All right. All right. So this one's here is kind of also very fun and interesting problems. And Nice talk to you, nice work with you together on this problem. So have a good day, and let's take a look at what problem we're going to work on the next video. All right, have a good day. Bye.